As already introduced in the previous part, a strong link between appropriate technologies and energy access and use for local sustainable development is present. Focusing on electricity generation, some commonly used technologies are small wind power plant. It is based on conversion of wind energy, mechanical energy and final AC electricity. Different designs of wind turbine are available with different shapes and sizes, permitting to apply this technology at different scales and at different level of complexity. Small wind includes microturbines with power lower than 20 kilowatts and mini turbines with power between 20 and 100 kilowatts and towers shorter than 30 meters. This is ideal for do-it-yourself approach using local materials for blades and tower and common generators. This approach increases the affordability of the technology and promotes a local maintenance and maintaining, especially for micro wind turbines and small mini ones. Usually preferred to other technologies for larger scales of order of dozens of kilowatts, scalability of the solution is linked to the structural design. In large-scale power plants, size of tower and blades increases, requiring particular attention to bases and tower resistance to avoid structural collapse. Reliability of this technology is strongly related to the assessment campaign for wind velocity and frequency evaluation. Knowledge of wind local conditions at scale of 100 meters is very important to increase energy production and reliability of this solution. Related to the aleatory nature of wind source, this solution is often coupled with storage systems and other technologies like solar photovoltaic systems. Small hydroelectric plant. It generates AC electricity converting potential energy of falling water in mechanical energy through a hydraulic turbine and then in electricity using an alternator. Power turbine used in the plant can be traditional or pump as turbine typology, where a pump, usually cheaper and more common than turbine in developing countries, is used for power generation. This solution requires particular attention during the design process to adapt the hydraulic system to the pump characteristics and avoid to damage it during its use. Small-scale hydro plants are divided in pico, micro and mini with power from 5 kilowatts to 1 megawatt, increasing the complexity of design and requirement of civil infrastructures with power. Environmental impact of this solution is mainly linked to wear and intake parts, eventually influencing the morphology of the river used for feeding the power generation turbine. Based on high minimum size, hydroelectric plants are commonly used for community supply. The initial capital cost per unit of electricity produced can be lower than other renewable technologies depending on required works about water capture and related civil infrastructures. Hydroelectric plants are highly reliable with seasonal variation of generated energy based on the water availability. Furthermore, this technology can be used as part of storage systems, pumping water to accumulate potential energy to be converted when necessary and increasing the reliability of the whole energy system. Maintaining this kind of technology is simple and ordinary maintenance can be managed by local technicians. The presence of the mechanical parts requires specific skills in case of damages and replacement of broken components. A common part of most of energy systems is the electricity storage, which represents a fundamental component for autonomous energy systems, especially when aleatory sources are used. This can be provided through different technology solutions. Deep cycle and car batteries are commonly used and often already included in standalone energy packages. More specific solutions strongly related to the context of application are long-duration flywheels, electrochemical capacitors, compressed air energy storage, and pumped hydro. Electricity storage represents nowadays a resource for reliability of energy systems and a limit from economic and maintaining point of view. In energy and all other fields where technologies are required, their appropriateness is represented by technical and extra-technical characteristics, including social, environmental, and economic aspects. Moreover, the context of application and use determines their appropriateness especially in developing countries and remote rural areas where they can represent the main tool to achieve a local sustainable development.